This is group 2. We're going to be talking about our biologically inspired design with respect to impact protection during transportation. Now, before we talk about our design, we need to talk about why our design is important. There are two main reasons why impact protection during transportation is important, and both of them relate to the amount of resources used during production and transportation. If a product is damaged during transportation and is unusable, that means that the product has to be replaced. And if the product has to be replaced, that means that the resources used in the initial production and transportation are wasted, as well as the resources used in reproduction and reshipment of the product. It also means that if the product is damaged during shipment but is still usable, that the life cycle of that product is reduced. If the life cycle of that product is reduced, that means that the product has to be reproduced sooner. And that means that more resources are used overall in the long run. Now, here are two examples of impact protection in the bio world. The two ones that we have are a woodpecker's skull and a fetus in utero. With the woodpecker skull, you can see that it has a multi-layered design where it's got soft bone and hard bone. It's got the hardness of the beak. It's got the elastic of the tongue that wraps around the head, and it's all used to protect the brain, which undergoes around 1,200 Gs of acceleration during the pecking of the wood that a woodpecker does. And then with the fetus in utero, as you can see, it's also a multi-layered design that uses muscle, fat, amniotic fluid, and uterine lining as its multiple layers to provide impact protection to a fetus as it's gestating. Now, moving on to the feature that we've chosen to mimic in our design. The feature that we've chosen to pull from is the fetus in utero. It has a high impact resistance. It's able to protect the fetus from a lot of strong impacts. It allows protection from all angles in its design, and the multi-layered composition protects from multiple different types of impact, whether it be slow but constant or quick and forceful. It provides protection from a lot of different types of impact. The feature does have challenges, though. There are three main types. Two of them come from the multi-layered composition. It adds complexity to the production and complexity to the recycling of the product. If a product has multiple different layers and they're not all the same material, it requires extra time and resources in the production as well as in the recycling in order to get the layers put in properly to add that protection and to get them removed safely for recycling. And the materials used can be difficult to manufacture sustainably. And as you can see in our design later, you'll see how we try to tackle those.
Taking inspiration from how fetuses in utero have fluid around them to absorb impacts. The design will feature an aluminum enclosure that will contain a thick gel and a stretchable silicone bag in the middle. The stretchable silicone bag hugs any item that is inserted into it and also ensures that it is kept centered inside the box so that it is always protected from multiple impacts. Thick gel inside the container is what will be doing the absorption of any impacts and vibrations. The lid of the box will also have a silicone bag attached to it to cover the whole of the box and protect the top of the item. Process to manufacture the box. The aluminum sheets will be cut to dimensions and joined together by welding. In industry, silicon can be obtained in the form of rolls. The material from the silicon rolls will be cut to shape to form the dangling bag and the bag attached to the lid of the box. The thick liquid inside the aluminum box will be cooking oil, and it will be inserted into the box by valves that will be made on the aluminum box and lid. Raw materials and energy consumption. The materials used to manufacture the impact protection box will be recycled cooking oil, recycled aluminum in the form of sheets, and silicon rolls obtained from manufacturers. The process will require electricity for welding and pumping of the oil into the box, and also fossil fuels to transport the silicon and cooking oil to the manufacturing site. Waste from the process. Since the aluminum sheeting will be cut to shape, it will produce shavings and scrap material. These scraps can be remelted into aluminum sheeting and used to make more of the product. Since the recycled cooking oil will need to be filtered before use, there will also be waste filters produced in the process. Since silicon, like the aluminum, will need to be cut, there will also be waste material produced from the silicon.
Waste recycled from one process to this process. We plan to use a recycled aluminum to construct the outer box. This aluminum can be recycled from cans, cars, aircraft, wires, cookware, construction supplies, etc. Using recycled aluminum as opposed to deriving it from raw materials saves about 90% of that energy. We're choosing aluminum over other metals such as steel. It's lightweight, still durable, it's easily recyclable, doesn't rust, and it's relatively cheap. For the silicone membrane, we plan on using recycled silicone. We're going to use a company take-back program, as it's not often recycled. We can melt it down to reshape into the membrane. It's slightly better for the environment than plastic, even though they both degrade about the same rate every 400 years or so it takes for them to decompose. Plastic still leaves like bead-like material in the ground, where silicone doesn't do that. It's relatively cheap, it's lightweight, provides use for unwanted silicone. For the thick fluid, we'll be using recycled cooking oil. It's a cheap and effective way to recycle used cooking oil. You can use cooking oil 2 or 3 times for cooking. Obviously, you got to filter it out each time before it just kind of loses its ability to be used for cooking. We can take that used oil and then use it for this process. It'll provide a thick packing insulation. This will help prevent whatever the contents of the shipping box from being damaged. The other nice thing about cooking oil is it's biodegradable. It won't harm the environment even if you pour it directly on the ground. So the life cycle of the product, the aluminum box will be constructed from recycled materials, as we said. It can be reused several times, and then can be melted down later in the event that the box becomes too banged up or breaks or something. The silicone membrane will be made of recycled materials, again, as stated. It'll likely be torn and only used once, because we're kind of picturing it as almost like a bag on the inside of the package. It can also be melted down, as we stated before, to be used in its basic oils to construct another membrane. The thick fluid packing insulation, that's our cooking oil. We'll need to filter it out, obviously, and it can be reused, almost infinite number of times. And if we get a box that leaks or something, it won't harm the environment. The 100-year impact in 2121, sustainability in shipping has changed immensely. Recycled cardboard boxes are still used on a small scale. Plastics were replaced with recycled silicone. The basic idea was reused with air as a fluid instead of oil to save weight. Shipping containers have been modified to adopt this shipping process, loaded from the top, filling a silicone membrane bag with products, and then the space around that membrane will be filled with a new synthetic sustainable oil. Some aircraft have also adopted this idea to potentially prevent mishaps due to cargo shifting in flight.